Okay, let's look at our next problem. This problem will really emphasize the idea of having an initial scenario, having a final scenario, and then trying to link the two together. It's exactly as we've solved all of the other problems, but now I actually put a visual to it so you can see exactly what I'm saying. One side of a rectangle is 4 centimeters shorter than the adjacent side. If we increase each side by 2 centimeters, then the area increases by 20 centimeters squared. Find the length of all of the sides. These types of problems are not difficult. Here you simply have a case where you're given an initial scenario, then there's a change to a final scenario, and there's a link between the initial and final scenario. So let's draw this out. Right, watch here. Let's call one side of the rectangle x. Why do we call it that? Because it's unknown. It's given that the adjacent side is 4 centimeters shorter. So if this is x, the adjacent side will be x minus 4. Then we're given that we took each side of this initial triangle and we increased it by 2 centimeters. So this will become x plus 2 centimeters. This will become x minus 4 plus 2. Again, look at it for what it is. Don't ask yourself what is x minus 4. X minus 4 is the measurement of the one side of the rectangle. So therefore, we're just going to add 2 to whatever it is. So this will give us x minus 2 and the top will be x plus 2. Right. Then they say that once we increase it by 2 centimeters, the area increases by 20 centimeters squared. If it increases by, what increases by 20 centimeters squared? The initial area. So how do we find the initial area? See, that's very important. That's why the word increase by is, and increase to, and understanding the distinction is so important, because increase by means you need to add this 20 centimeters cubed to something. But what is that something? It's the initial area, right? So therefore, how do you get the initial area? It'll be x times x minus 4. And in the final scenario, we know that whatever this yields, whatever A1 yields, when you add 2 centimeters to each side, it will be the area of A1 plus 20 centimeters squared. See, the area of A1 plus 20 meters squared. Can you see how we're linking the initial to the final scenario? Right, so that's one. But there's another equation that we can create here, which is x plus 2 centimeters and times x minus 2 centimeters. So the area of this rectangle here, we can find it by taking the actual dimensions and multiplying them. Okay, so this is what I want to do. I have two equations. Area 2 is equal to x plus 2 times x minus 2. And area 2 can also be expressed as x times x minus 4 plus 20 centimeters squared. Right? And this is what I really want to emphasize. How many variables do I have here? I have one variable and I have another, x. So we have two variables. Two variables. How many unknowns do I have? I have two unknowns. So what must we remember? When we have two unknowns, we need the same number of equations as their unknowns. So how many equations do I have here? I have 1 and 2. This is why most of you are probably asking, how did I know to create another equation here? Like, how did I know to take this dimensions and create another area and then equate and solve? We know this because we have two unknowns. And to have two unknowns, because we have two variables, that's how I know we have two unknowns. To have two unknowns, in order to solve for both, we need to have two equations. Right? So we have to solve for this. What can we do? Let's solve simultaneously. So what we can do now is we can call this here equation 1. We can call this here equation 2. So what we can say that x plus 2 times x minus 2 must equal to x into x minus 4 plus 20 centimeters squared. Now, the reason why I'm keeping this 20 centimeters squared is because it's an area. It's a unit of area. Right, so that's why we're dealing with only area. See on this side here, this will be centimeters squared. This here, centimeters times centimeters will be centimeters squared. So we're dealing with all centimeters squared. All of them will be what? Like terms. This is why we can solve them. Right, anyways, let's go. X times x is what? X squared minus 2x plus 2x is 0. And it'll be minus 4. If you've seen this, this will be a sum and difference of terms. So that we're dealing with a product here. So therefore, we'll use the SMS rule. Square the first term, write the minus sign, square the second term. Here I'll have x squared minus 4x plus 20. Right? Then the x squared and the x squared will cancel. So we're left with 4x is equal to 20. Add by 4 on both sides, 24. Therefore, x is equal to 6. Now you see, at the beginning, we defined x, we gave x a name. So when you're solving all of this here, just think of it as normal maths, normal algebra rules. But when you come at this point here, once you solve for x, it's very important to go back to the question and ask yourself, what did I call x? What did we call x? We called x one of the sides of the triangle, so therefore this is 6 centimeters. To get the adjacent side, we know it was 4 centimeters shorter than that side, so therefore it'll be what? 6 minus 4, which will be 2 centimeters. That's 6 centimeters. To get the final scenario, we can take it as it is. We could say, okay, you know what? It's 6 centimeters plus 2 centimeters, which is what? 8 centimeters. This will be 2 centimeters plus 2 centimeters, which is 4 centimeters. Or you could just look at the mathematical equation, which was x minus 2 centimeters. And we could just say it's 6 centimeters minus 2. So can you see how we can get to this same answer in two different approaches? I could say, look at this measurement here. What's the actual measurement? It's 2 centimeters. We know that we did some change. We added 2, right? So therefore, we can get to this measurement by saying 2 plus 2, which is 4. Or I can look at the mathematical relationship, and I could say that it's just the one side of the triangle less 2, right? Or it's the longer side of the triangle less 2. That's the mathematical relationship. So therefore, it'll be 6 minus 2, which is 4. Two different ways you get to the same answer. That's the power of math. You can look at it in terms of what the equation tells us. So this is telling us what the relationship is, right? Or you could just say, you know what? We had one side here to be 2. We increased it by 2. So therefore, 2 plus 2 is 4. Right? This will become very important when we start talking about calculus. Yeah, so we were asked to find all the lengths of all of the sides of the triangle. We've already found it here. Right? 2 centimeters and 6 centimeters there. And that's how you solve a problem of this nature. So you can see here, if you read through all of this, from the initial scenario, we can express the area as a product of the sides of the triangle. So from the initial scenario, we can express the area as a product of the sides of these triangles. And we'll call this area 1, since it's the area from the initial scenario. We're then given some change, which is increasing the sides by 2 centimeters. So we added 2 centimeters to both sides. So now we can go to a final scenario. So for the final scenario, we can re-express the sides and find the area of this sides as a product of the lengths of the initial scenario increased by 2. Right? So that's a lot of words. But basically, we can say, to get the area of this final scenario, it's the product of these two sides here. Right? Because we took whatever this side was, we increased it by 2. We took whatever this side was, we increased it by 2. And now we can find the area. And that's what we get there. Now, this is the important part of the problem, because we must somehow find a link between the initial scenario and the final scenario. Otherwise, word problems will not work at all. If it is given that the final scenario will yield an area that increases by 20 centimeters squared, we can re-express the second area as a sum of the first area and 20 centimeters squared. That's the second equation. Right? So it's a lot of words here, but I just explained it to elaborate on everything that I've just said. And yeah, and since we have two unknowns and we need to get two equations, that's the reason why I strategically chose two equations, and then we simply solve. As you can see, I simply solved. And everything's everything's discussed neatly. You can even see I emphasize the idea. Now, after we solve for the variable, it's important that we go back to the problem and familiarize ourselves with the meaning of the variable. In this case, we said that the variable x is the longer side of the rectangle in the initial scenario. Right, so that's very important. Here, you're using all algebraic techniques to solve. But when you come to this point here, you come back into the practical world, where you have to realize what did we call x. Right, so that's how logic works. And then at the end here, you can literally just solve all of these variables. You can see what I did here, and you can get your answers. So that's about it for word problems.